Okay, let's start. Good evening, everyone. Thanks for joining in. And agenda for this meet is to have revision for the and term quiz for Industry 4. So already we had one revision quiz, I think 4 days back. So we will be going through that, and the same document I will be covering. So Industry 4 in last we have got PYPs. So we will be solving the PYPs, and along with the questions, then we will touch upon the main concepts also. I hope my screen is visible to everyone.
Yes, it's
Yes, sir, it
visible.
is.
Yeah, sure. Okay, let's start. Okay. So I hope this PYP, this screen is visible. Questions are there. Okay. Okay, so this is from December 2023 question paper. Which of the following functions logistics management does not cover? So options are supply management, materials management, distribution management. So we know that they are the part of logistics management. Logistics management basically deals with the inventories, transportations, and we can say with the supply management. So only the customer management option, which is number three, it is not applicable. So that is the correct option. What is the last mile in a supply chain? So last mile in a supply chain is always store to the customer, and the first line or the first mile is from the vendor to either warehouse or to the distribution center, depending upon the size of the business. The second mile is from warehouse or distribution center to the store, and the third mile is to the customer. So that's covered. What is the disadvantage of product layout? So product layout, what is the meaning? That we have got the workstations and we work on workstation, we do one activity, then we come to the next workstation and do another activity or the combination of some activities, and then we go. So it is like a sequential work. And what is the main disadvantage in that? That if one of the workstation gets goes unserviceable, so your entire work comes to a halt. So the last option which is there, that it is not very robust if there is a disruption, that is a correct option. And if you see other options, limited opportunities for the use of specialized equipment, no, the specialized equipment can be used at the workstations. High per unit cost for production, no. In fact, by doing this product layout, the cost generally comes down. Movement of materials is tedious, no, that is also not true. So the last one is the main disadvantage. Identify the correct progression of industry. So we know that from steam engine we can to assembly line, then to IT, and then to IoT, and accordingly we can select the option. The production rate of an assembly line is determined by what? It is always determined by the activity which takes the maximum time. That is the slowest station. So this is the first. This we will see in future also. We'll be solving some questions, calculations on the basis of this. Okay, what is the decision variable Xij denotes in vehicle routing problem? That is the VRP. So in the vehicle routing problem, when we do that, there is a store and we have to send the vehicle and we solve that problem. Xij is always denotes is equal to 0 or 1. It's a binary. 0 means that it is the vehicle is not traveling from I to J, and 1 means it is traveling from I to J. Okay, which of the following examples can be referred as cyclic patterns? So there are different types of patterns. Examples are seasonal patterns. I have all the types of patterns here defined. So there are trend patterns which are a long-term increase or decrease in the data. Seasonal patterns which have got a regular fluctuations. Cyclic patterns, they are the patterns that occur at irregular intervals. So these are like the stock market crash, pandemic. These are the, we know that they happen, but at irregular intervals. So coming to the question here, so economic recession is one type of cyclic recession. The keyword is that they happen at irregular intervals. Increases ceiling fan sales during winters may be due to the off-season discount. So this is a seasonal pattern. Increased tourist footfall towards the end of the year. It's a seasonal pattern. This is from the DL. Okay, this is a question. Pranjal is shopping in a departmental store. He has a list of items which he prepared at home itself. He picked up a few packets of tea as part of his list. He could see coffee packets and milk powder packets in the neighboring shelves. He picked a few milk powder packets. However, these are not part of his list. The key sentence. He was searching for a good day biscuits. He could identify only one packet in the shelf remaining. However, there were a lot of Sunfish biscuits lying in the next shelf, so he picked 10 Sunfish packets while he needed only two. Now map the scenarios with the items below. So in this, there are different types of scenarios I will cover here. One is called, okay, one is called substitution. Substitution, for example, he had tea in his list, but the tea was not available, so he went for coffee. So that will come in the substitution, which is not applicable in this question. Complementary means that he had tea in his list. Now, what complements tea is milk, or we can say sugar. So he picked up milk, so it will come under the complementary part. Tea, coffee is substitution. Tea, milk, powder packet is complementary. Good day biscuits he wanted to have, but they are not available. Only one packet was available, so he went for Sunfish biscuits. So this is a part of inventory dependent demand. So the good day was not available and he went for Sunfish biscuit. So this is an example of this. Now, what is an example of impulsive buying? It is not there. So maybe he was at the counter and he saw few chocolates and he picked up. They were not there in his list, but he picked up. So that will be the impulsive buying. That it is not there in the plan, and while browsing Amazon or in the departmental store, we pick up something. So that is impulsive buying. Select the correct form of internet from column B corresponding to the example in column A. I think this is from week 9 or week 10. The uses of internet, where the internet uses can be consumer, commercial, industrial, and private, depending on the nature of the internet in this. So we see smart metering. Smart metering will come under the industrial use, where we use the smart meters in the industries. Banking system is a commercial one. Entertainment integrated devices like our Alexa, it is a consumer based. Okay, which of the following model corresponds to exponential smoothing forecasting model? So we have seen again straight away from the lecture, it is ft plus 1 is equal to alpha dt plus 1 minus alpha ft, where alpha is the smoothing factor. Exponential smoothing. Rest option, okay, this option you can see that there is no smoothing factor. Which of the following is not an example of digitization? So there are three terms. One is digitization, another is digitalization, and third is digital transformation. Digitization is just copy analog to digital. When we convert something to digital format, so that is digitalization. For example, scanners converting a document to digital format, or we have got data feeding into Excel sheet. All of them, they are the digitalization. When we apply the digitization or this two processes, then it is known as digitalization. And when by doing that there is a transformation in how do we do the business, then it is a digital transformation. So we see the options: scanning a document to get the PDF document, it is digitization. Converting a physical 2D sheet to CAD drawing, it is also a digitization. Converting physical invoice to e-copy, it is digitization. Creating an automated report from the existing cost data, it is not digitization. It is, we can say it is something called digitalization, where we are deriving some automated report. Till now, any question, anyone?
No, sir.
Okay. Next one, you visit the car service center to get your car washed. In the service center, washing done using automated system. Example, the car is put on a moving belt. Water is sprayed, drying is also done. Which of the following term representing the scenario? Digitization, no, it is not happening anywhere. Automation, yes, everything is automated. Digital transformation, no, we have not applied any digitalization in this. Choose the situation from the options below in which a facility layout problem is relevant. What is a facility layout problem? That what will be the layout of the facility and whether we will have product layout or for the process layout. So when it is relevant, a new facility is added. Yes, that is the time we have to take that decision. A new product is introduced. Yes, that time we have to take the decision. A new service is introduced. Yes, we have to take that decision. Or there is a shift in technology. We have to take that decision. So in all cases, the facility layout problem is relevant. Which of the following supply chain costs is or are affected by the distribution network structure? That what is the distribution network structure, and what are the things which get affected by that? So inventory, yes, it gets affected by that. Transportation cost, it gets affected by that. Facilities and handling, yes, they get affected by that. Information, yes, it gets affected by that. Price, does price gets affected by that? No. The price is always dependent on the demand function. We know that from managerial economics. Many of you can wonder that if in case the supply chain cost goes high, the price will go high. No. If the chain cost goes high, that the firm will be at disadvantage and it will be earning either less profit or will be occurring losses, because the price is always dependent on the market dynamics, that what is the demand in the market. Calculate the Euclidean distance. Piddly, I'll leave that. There are four demand points at A. The coordinates are given B, C, and D. The respective demand at these points are 7, 1, 3, and 5. Select the optimal location based on the cross median approach. So this is from B3 problem, and we have to find the median. So how to solve this problem? What do? We plot okay, these points. So we have got maximum is 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So first point is 1, 2. So this is A. Demand is here 7. 2, 3. Here is B. Demand is 1. 3, 5. This is 3, 5 somewhere here. C, and demand is 1. Oh, sorry, 3. And 5, 4, 1 is point here, and the demand is 5. So how to solve this cross median approach? We do vertically and then we do horizontally. So if you do horizontally, if you make it, so this is 7, this is 8. So here we come 8 at point 2, and 3 plus 5, 8. Again, it comes at 3. So this is the point where the horizontal, your median is there, 8, 8.
Oh, sorry.
Now, yeah.
What if there were like 5 points, A, B, C, D, E? Then what's the procedure?
Then the median which is there, okay, then you go in the median. And how we used to calculate the median in the machine learning foundation course, that you got points 1, 3, 7, 9, 8. So you'll find the median somewhere here.
Yeah.
Okay. So those will be the point okay, for your median. If you're getting actual median.
So basically, you add up all of these 4 and just basically find the median on these.
Oh, so this gives you basically to find the actual point. Always you use the Euclidean, or to find the approximate point. For example, you have been given 6 different points, and you want to find the actual one. Then the approximation is by using the COG, and we have got one question where we will be doing that in this PIP only. So this is specifically they have asked by using the cross median approach, and they have asked that which one are possible by using this. Is it okay?
Or
okay. Now similarly, when you do vertical, you will come to know that when you reach 2, here it is 12. So your point which is there, the cross median, it will not be after that. It is before that only. So you have got, this is your coordinates where that you have to select the optimum location. So when you select the optimum location, it is 2, 2. Yes, this is 2. This is 1, 2, and 2, 3. So 2, 2 is possible here. 3, 2 is possible. Yes. 2.52 is possible. It will be somewhere here. Here. And 2, 3, is it possible? 3, can you go? No. 3 is not possible. So these are the three possible optimum locations. Now, same thing, if they would have passed a COG, then you would have used the COG function that I will just cover in the next question. Okay, the process layout is also known as functional layout and batch production layout. Just remember this. These are the two terms which are akin to process layout. Okay, this is the same question that day we had done, the same diagram which is there. I have covered. Okay, this is an interesting question from week 1 and week 2. A factory works for 2 8-hour shifts each day, produces a total of 24,000 electric bulbs using a set of workstations. There are 8 activities required to manufacture the bulb, such that the sum of all activity times is equal to 12 seconds. How many workstations are required to maintain the specified level of production, assuming that activities can be combined into these workstations in any order? Enter your answer in integer value. So in this, what the steps we have to follow here, they have given us the total time and they have given us the output. So from here we find the min cycle time, and min cycle time is equal to total time divided by output. So your total time is 2 into 8 hours shift, and it is in seconds. So 60 into 60 divided by 24,000, which comes to around 2.4 seconds. This is your min cycle time. Number of workstation formula is straight away is total time for all activities and divided by the min cycle time. So total activities, they have said total time is 12 seconds. So your number of workstations will be 12 divided by 2.4, which comes to 5. Okay, there was a question on the WhatsApp that how to find min cycle time, so that will come. So I have jotted down the again important concepts. Min cycle time is equal to total time divided by output, and number of workstations is total time for all activities divided by time of activity with the max time. That is the min cycle time. And formula for percentage idle time, that is sigma of summation of activity minus min cycle time divided by number of workstations into min cycle time into 100, and efficiency is 100 minus percentage idle time. Okay, next question is from the newspaper model. Ramu puts up a stall for Diwali light diya every year. He builds a diya at a cost of rupees 3 and earns rupees 5 by selling each diya. Any diya not sold by Diwali will be discounted to rupees 1. From his experience, Ramu knows that the demand is uniformly distributed within 800 to 1000 units. Answer the given sub questions. What is the critical ratio? So in the newspaper model, there are two things which are important. One, in the newspaper model, one is the ordering cost. Ordering cost is the cost which he foregoes if he doesn't have that. So that is basically the profit. And this is selling price minus cost price. Second is the salvage cost. Salvage cost is a cost which he is losing out by not selling that. So that will become CP minus your salvage price, salvage cost. And the formula in newspaper model is that your Q star is equal to root of 2 into total demand over into CO by CS or CC, whatever you want to denote. So this is the formula. So critical ratio, first we find, oh sorry, I just jumbled up. Okay, sorry. This I had covered. Okay. This is the EOQ model. This I have covered correctly, CC. And critical ratio which is there, critical ratio is CO by CO plus CC. And now this critical ratio is used for finding the Q star depending upon the distribution. So in case it's a normal distribution, so what do you do when you get this CR? For that, if it is a normal distribution, you find the value of Z from the normal distribution table corresponding for this CR. And then Z minus mu by standard deviation, it becomes your this value. And then you find. But in this question, because the Z and that we cannot do, so they have given us the uniformly distribution. For the uniformly distribution, Q star becomes A. If it is a uniform distribution AB, then your Q star will become A plus CR into B minus A. Okay. And I have covered it for the normal distribution also in case that question comes. So you get the Q star. This is the optimal order of quantity, which will minimize the Ramos total cost. Percentage change in the order quantity if the demand support changes to 500, 700. So in that case, only your Q2 will become, apply the formula 500 plus 0.5 into 200, which becomes 600. So change is Q2 minus Q1. So this is minus Q2 minus Q1 divided by Q1. So this will become 300 by 900. So it is minus 0.33 or minus 33%. Any doubt, any clarification till now? Anyone? Abhi?
No, sir.
Okay. 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 So this is a question where it gives a doubt. Again, Rana Bakery, a company, is using a layout which consists of 9 workstations. 200 sandwiches are produced in a day on this layout. A typical day consists of a single shift which runs for 10 hours. The sandwich making process consists of 9 activities. The information is provided in this below. So again, we follow the same steps. If this information was not given in the question, then what do? We use the min cycle time from the table. However, this has been given that in this time, for 10 hours, he's producing 200 sandwiches. So what do? We find the min cycle time from total time divided by output. So which comes 10 into 60 into 60 divided by 200 is 180 seconds. And this 180 seconds is the time now on every workstation. And they have given how many? That for 8 hours consists of 9 activities, and they have given 9 workstations. So for every workstation, you have got time available 180 seconds. 180. Okay. Now percentage idle time, how do we do that? We minus this from 180. So 160, 170, 120. Sum it up and divide it by number of workstations into min cycle time. So it comes 88.88%. And efficiency is 100 minus 88.88. So for efficiency, it is not necessary that you first calculate percentage idle time and then you do efficiency is equal to 100 minus percentage idle time. You can straight away do efficiency is equal to summation of time which is there on every workstation divided by number of workstations into min cycle time into 100. So this also straight away can be used. Okay, so this we have done, and this is a question of balance. Suppose you are responsible for material purchase in an organization. Your demand forecast for a product of next 4 weeks, which are 3, 4, 2, and 4. You need to purchase one type of raw material to produce the final product to meet the above demand. Consider 1 unit of the final product requires 1 unit of this raw material. Whenever an order is placed, your organization needs to incur a cost of $4, which is a fixed cost irrespective of the quantity per order. Purchasing cost of the raw material is 2 per unit. This is the variable cost. Holding cost for an item not gone for production at the end of the week is $0.5 per week, that is 50 cents. You can order a maximum of 5 units in a week. This is the constraint. and the warehouse has the capacity to store up to 4 units of inventory. That is also constraint. Note that you need to meet the demand in every week, and we have to find that how much we'll be ordering at every stage. So it is a bellman, and we had discussed during the revision for quiz 2. However, I will go through it quickly. So how do we do that in a bellman? We start from, so there are three states: S0, S1, S2, S4, S3, four states. So we start from S3. At the end of S3, we always state that balance is 0. Now at S3, the state can be either 0 or 1, 2, 3, or 4, because maximum is we can carry only 4. So for this, all these states, we find the cost of at F40. So at F40, if it is 0, so he has to order, there is a fixed cost 4, then 2 into 4, so it becomes 48 plus 12. So these are the trivial calculations for F4. Similarly, F41 will come 10, 2, 8, 3, 6, F4, 4. So these are the trivial ones. Now we come to S2. Now at S2, the state can be either 0, 1, 2, 3, 4 again. And the demand is, there is a demand at S3, which is 2. So 3, 4, 2, 4. Demand is 2. So at 0 state, for example, then now we take 0. At 0, how much he can order? He can order 2, because he has to fulfill his demand. So in that case, he orders 2. This is the ordering cost. Holding cost is 0, because he will consume both 2 and he will not carry anything. Now he's not carrying anything, so F40 will come into play and we will use that cost. So this will become 8 plus 12 is equal to 20. Now if at 0 he orders 3, carries 1, so it is 0.5, and here we use F41, so this is 20.5. At 0 he orders 4, consumes 2, carry forward 2, we use F42, this is the value. F305, this is the maximum which he can order. Orders 5, consumes 2, carry 3, this is the carrying cost, and this is F43. So for 0, we have got these values. Similarly, for 1, he can order 1, 2, 3, 4, 5. We find those values. Similarly, for 2, he can order 0, 2, 4, because maximum he can carry 4 only. That's why the maximum he can order 4 only in this state. We get the values. At 3, he can order only 0, 1, 2, 3, because he cannot carry more than 4. So these are the values. S4, he can order only 0, 1, 2. So now we have got the state for S2. Now, next one, we come to at 2, S can be 0, 1, 2, 3, 4. This we have already done. Now we come to, this was for S1. By mistake, I have written S2. So now we come to S1. Again, it can be 0, 1, 2, 3, 4. So we use the same things, and demand is here 4. So he has to minimum order 4. So he can order either 4 or 5. And here we'll use this. At 1, he can use 3, 4, 5. S2, 2, 3, 4, 5. S3, 1, 2, 3, 4, 5. And by doing this, now we will come to S0. Now at S0, we always assume that we are starting from 0. So at S0, his demand is 3. So he has to minimum demand 3, or he can demand 4, or he can demand 5. So these are his quantities which he is getting. And from here, we can make out that this is the lowest. That when he orders 4, it is the lowest. And from where it is coming from F21. So at stage 2, We go to F21, see how much he is entering, and then we will get the next step. So this is how we get the solution. You can go through this document. Calculations are very, very easy. Only we have to remember the steps and how much he can order, how much he can carry, and how to interpret this is here. So in one of the PYP, they have asked this question. I hope they don't ask, but we will be having good amount of time tomorrow, so we can solve it if we remember the state. Any question, any confusion in this question, any doubt, anyone? I can cover it again. Abir?
No, sir. No
Yeah,
doubt.
yeah. We have done this 2 times earlier during quiz 2 preparation also in earlier revision session. Okay.
Yes, sir.
Some theoretical concepts about this only, that what does the state variable represent. So state variable was that S, and when we said S2, so it is the beginning inventory with the warehouse in the each week. So this is S1, S2, S3. So if we say S2 is equal to 2, this is the beginning inventory of 2. What does the action set represents? As action set represent that at S2 is equal to 2, how many I can order? What are the action sets? I can order if the demand is, for example, is 2 only, then I can order only 0, 1, 2, 3, and 4, because the maximum I can carry 4 only. So this is the action set. What actions I can take? What is the objective function in stage 3 when the state variable is 2 and your action is 0? So this means this is the F3 2, state variable is 2 and action is 0. So we go to our previous page and find the value of this, and in this case the value was 12. Okay, so this next question is from week 9. Suppose you need to accept reservation for a flight. There are total 100 seats in the aircraft. You have 2 classes of passengers, economy and business. One economy seat gets you 2,500 rupees revenue, while a business seat gets 7,500 rupees. From your experience, you know the demand for business travelers follows a uniform distribution of 10 to 40. Answer the given subsequent questions. So this is very, very similar to the newspaper problem. Only here, the CR which is calculated, it is calculated in a different fashion. So here, what do we call it? We call it as PY star, and this is equal to 1 minus price of the economy divided by price of the business class. So in this case, it will become 1 minus 2,500 divided by 7,500. This will become 1 minus 1 by 3 is equal to 2 by 3. Now this PY star which is there, this we use now in the distribution. So this is for the business travelers, and PY star is also for the business. So from here we get the protection level. Always remember, protection level is used for the business class, and it will become A plus this, we have got PY star into A B minus A. So this will become 10 plus 2 by 3 into B is 40 minus 10 is equal to 10 plus 2 by 3 into 3 is equal to, 10. So 10 plus 20 is equal to 30. So your protection level is 30. These are the number of seats which you have to keep for business class. And for economy class, the term which is used is as the booking limit. Now booking limit will become total number of seats minus protection level, which will become 100 minus 30 for this case is equal to 70. In one of the PYP, they have incorrectly written booking as protection and protection as booking. So that Dr. Jamini had clarified, it was a mistake on their part. So don't get confused by that. I hope this is clear to everyone. Booking limit, protection level, how to find out. Any doubt, anyone? Anyone wants me to repeat this? Afnan? Okay.
No, this is fine, I think, yeah.
Yeah, okay, good. Okay, next, which of the following examples can be referred as a seasonal pattern? So I had covered it. Seasonal patterns, they always follow regular intervals. It can be anything. So economic recession, no. Increased ceiling fan sales during winters, maybe due to the off-season discount. Yes, it's a seasonal. Increased tourist footfall towards the end of the year. Yeah, that may be a seasonal. So with this, we have completed December 23. We come to April 23. Okay, in which of the following scenarios a facility layout problem is relevant? This is repetitive. Already we have covered. Select the disadvantage of a product layout from the following. Lack of flexibility. Yes, because why? Because it is sequential. We are going from one workstation to another workstation. So I cannot do this activity before this. I cannot do this before this. So there is a lack of flexibility. High risk, if a machine breaks down, then the entire line stops. So I had covered this. So for example, here the machine has broken out, then your entire line stops. So this is one of the high work in process. No. Need specialized supervision. No. The process layout needs the specialized supervision. Remember that. Okay, what are the inputs for an order up to level calculation? That we are doing a business, we have got something, and I have to order up to level. I have to give an order. So what are the considerations? I have to consider sale forecast. Yes, I have to consider lead time. That how much time when I order, how much time it will take for the inventory to come. On hand inventory, yes, I have to consider that how much I have got, how much is the demand, how much I have to order. That and safety stock. Safety stock is the stock which I have to keep in case of any contingency, which will meet my demand for few days. So the safety stock in one of the PYP, it has been given no, but all these four are valid for the order to level calculations. What is digitalization? I already have covered when we apply the digital technologies to change the processes. So this is a digitalization. Pure analog to digital, no, it is a case of digitization. Process of moving towards a digital business, yes, it is a digitalization. Encoded in a digital format, no, it is a simple digitization. This is a Euclidean distance, metropolitan distance of Manhattan. I will not cover that. This is a simple question. Which of the following is or are considered in the vehicle routing problem but not considered in the TSP? Okay. So if we go through the options, any capacity restrictions and a specific starting point. In the TSP, the specific starting point is not given. Remember that. Okay, always it is given that these are the number of cities and what is the TSP. Whereas in the VRP, always there is a specific starting point. So that is any capacity restriction generally in the TSP it is not given. So these are the two options which are not considered in TSP, but in VRP it is considered. Subtour elimination, it is covered in both. Distance level restriction, this is a restriction we put, that is there. Subtour elimination we do in both. Okay, what brought the first industrial revolution? Again, remember steam engine to mechanization. 7 principles of IoT. There are 7 principles are there, and that this quality control is not there. Quality control we do with the help of IoT. It is not the principle. The principles are big analog data is there. We have to convert it. Constant connections it requires. It has to be in real time, and the spectrum of insights which is provided by the sensors of the IoT. Okay, what is the decision variable Xij denotes in the traveling salesman problem? So like we covered in the VRP, it is like the I and this is the J. Xij says whether Xij again it is a 0 or 1. It says whether the J was visited by the salesman just after I. Okay, so these two, if you see the English to me, they both look similar. However, I don't know the code scheme of I4. They thought that this second option is different. If the sales visit node J from node I binary, it is the same. If the sales visit node J immediately after visiting, so this might be that he goes somewhere and then he comes to J. So the most appropriate is the second, that he has to visit J just after I. But again, there is an ambiguity in this question. Which of the following is digitization, converting analog to digital? Conversion of
Excuse me. I'm sorry.
yes,
I'm
yes.
sorry to interrupt. Which one is correct in the previous one? Is it the second one or the first one?
Second option, immediately.
Immediately. Okay. Okay.
Yeah,
I get that.
yeah.
Thanks.
Okay, digitization, conversion of physical 2D drawings to CAD. Okay, it is digitization. Creating PLC logic in a microprocessor-based system to process data. So wherever there is a process, it is a digitalization. Okay, so it is not providing real-time maintenance schedule based on real-time machine performance. It is a digital transformation. It is not. So only the first part is the digitization. Okay. Now coming at EOQ, the order cost is what? Minimum, lower than the carrying cost, equal to the carrying cost, or higher than the carrying cost? Correct is it is always equal to the carrying cost, the order cost which is there. And here I have given the example how it is there when we use the EOQ formula. For example, demand is 10,000, ordering cost is 100, carrying cost is $2 per year. EOQ is 1,000. Now at this order 1,000 units, the total annual ordering cost equals the total annual carrying cost, and ensuring that the company is operating at the most cost efficient point. So remember this, the at EOQ, the ordering cost which is there, it is equal to your carrying cost for the entire year. Okay, this is straight away from the lecture. A factory has 3 workstations as given below. The time required at each centers are shown in the bracket. Calculate the efficiency of the system. So this, they have given 1.6 minute, 1.2 minute, 1.4 minute. So this is the question where we have to use minimum cycle time. So minimum cycle time will be what? It is a maximum time. So it is a 1.6. I have converted into seconds. So min cycle time will become here in this case 96. Number of workstations are how many? 3. So we find percentage idle time 96 minus 72, 96 minus 84, and 96 minus 96 will become 0. That's why I have not taken. Divided by number of workstations into min cycle time, and this comes. And efficiency is 100 minus 12.5. Okay. Now the next one, or this also, like I mentioned, this also can be calculated by summation of Ti divided by workstation into min cycle time into 100. So this will become 96 plus 72 plus 84 divided by 3 into 96 into 100, and you will get the same answer, 87.5. So we can obviate using this extra necessary step.
Excuse me. So two
Yes.
questions regarding this one. So
Yeah.
summation of TI is in
Yeah.
is the total activity time, isn't it?
Yes, 96 plus 72 plus 24, 84.
Yes, that is the total activity time, and that happens to be the maximum cycle time also. I think, isn't it?
No, no. See, maximum cycle time, max efficiency would have if this was also 96, this was also 96, and this was also 96.
Yeah. So then, okay, in that case, isn't it that it will become
In
the
that case,
sum?
it would have become 100%.
Okay. Okay.
Okay.
Okay. Yeah. But then TI is the total, like individual time, and then we sum it, so that becomes the total activity time, isn't it?
Yes, yes, yes.
Yeah. Okay. Sure. Sure. Thank you.
Yeah. Okay, this is fill in the blanks. We have to make out what are all these things. So again, it is straight away from the lecture. The white is A is the cost, B is the quantity. Now this E which is there, you see, which is increasing. Now the E is always will be the carrying cost. With the quantity, it is increase. This is the total cost which is there. The C which is there, it is the total cost. And this D which is there, this keeps on decreasing with what? This will decrease with the, this is the order cost. As the quantity increases, the ordering cost increases. So we can do the fill in the blanks on this. This was, I think it was asked in the quiz 2 also, if I'm not wrong. This question had come. Manhattan, we know metropolitan and Manhattan distances. Okay, this is a question of EOQ. A soak equipment company estimates its ordering cost at rupees 400, carrying cost to be rupees 2 per year per unit. The estimated annual requirement is 10,000 at a unit price of rupees 10. Calculate the given subquestions. What is the EOQ? So EOQ formula is 2D into CO by CC. We put it here. 2 into 10,000 is the demand. Cost is 400. Carrying cost is 2. So your EOQ is 2,000. Calculate the number of orders per year. So number of orders will always be D by Q. Total demand and what is the EOQ? So this is 10,000 by 2,000 and it comes that 5 times again we will have to give the order. Calculate the annual inventory carrying cost. So in the case of EOQ, what happens? We order, we finish it, order, finish it, order, finish it, and how many times we are doing? We are doing 5 times. And the average inventory which remains is the system is Q by 2. So your annual inventory carrying cost will be is equal to Q by 2 into CC. So this is 2000 divided by 2 into 2. It also comes 2000. Okay, while rechecked, Ashok Equipment Company finds that the order cost should have been 20% more than the currently estimated value. What should be the percentage increase in EOQ in this case? So current ordering cost is 400. With 20% increase, it will become 480. Now for 480, we find the EOQ which comes around 2190.89. So what is the percentage increase? Is 2190.89 minus 2000, which is 190.89 over the original value 2000. So this comes around 9.5%. Okay, so this is an interesting question which will I had said how to use using COG. Suppose a company wants to expand its logistics network and locate a new warehouse within a network of 3 existing facilities. The coordinates are these: A 200, B, and C. And the respective outbound goods volumes are this many: 2,500, 1,300, and 5,000. Determine the location of the new warehouse, round off the center answer to the nearest. So this question is solved by using the COG model. And what is the COG? For example, let location of the new warehouse let be the XY. So X will become 200 into volume plus 300 into volume plus 100 into the volume divided by total number of volumes. So this comes around 158. Similarly, you do for Y, you take the Y coordinate. So we get for Y. Now this is the center of gravity model, and always remember the center of gravity method will be quite close to if you use the your normal, if we change the X minus, we optimize this square plus Y square and Z square, but it will not be at that place. It will always be approximated. So generally in the business models, we use the center of gravity method to find this. I hope this is clear, and the difference between the median and the center of gravity method. Abir?
Yes, sir, it is clear.
Yeah.
Yeah.
Okay. So now this we have done. Metropolitan metric distance, we know that. Okay. So now this is a question with a little bit of twist here. Here they have given us the table only, and they have asked us that which of the following are the allowable grouping of activities to produce the product if the target is to have the maximum possible output. Okay, so in one of the P by P, they had also said here that one product is produced every 20 minutes. So we are not taking that P by P. And how to do this if this part is not given, and then I will cover how to do this if this is given. In case this is not given, then what do? We find the min cycle time. Min cycle time is the time, maximum time which is happening in this table. So this is 19. So your min cycle time is equal to 19. Then we calculate the total time, which is 109. Total number of workstations is total time divided by min cycle time. And you change it to the next integer. Okay, so in this case, it will become 6. So 6 is the number of workstations. Now we have to find that which these options are applicable for the maximum possible output. So first we see 1, 2, 3, 4, 5. This straight away we cut 1, 2, 3, 4, 5, 6. It is applicable. 1, 2, 3, 4, 5, 6. It is applicable for that constraint. 1, 2, 3, 4, 5, 6 for that constraint. Now there is another constraint which has been given. Now there will be now two constraints. First of all, in these possibilities, the time which is there, it cannot exceed again 19 seconds. This is the number one constraint. Then that on every workstation, you have to maximum time allowed is 19 seconds only. Is that clear? Understood?
Yes, sir.
Okay. The second constraint
Sir,
is
can you explain this part again, the 19 one?
okay. Okay. So the min cycle time which is there, it is the 19 seconds which we have calculated. We calculated the total time. We calculated using this total number of workstations. Now see 109 which are there, and we have got 6 workstations we have found. Now on every workstation, the maximum time which I can carry out an activity is 19 seconds, which is dictated by the min cycle time. Okay. This time is dictated by the min cycle time. And when we will come to this question, it will become 20. So this I'll cover later. So this is the first constraint, that on every workstation, the time which is there by every activity has to be less than equal to 19 seconds. So anyone which is not meeting this, you can cut it. Number one, that is the first constraint. Second constraint is that when you see these activities, so they have given the data for the preceding activity, that this A6 can take place only once A1 and A3 are completed. A7 can happen only when A1 and A4 are completed. A8 can happen only when A3 and A5 are completed. So then you apply the second constraint, and then you find out which are the feasible solutions. So I did that. You can do one by one. I had only one confusion, like these two. One was not meeting the time criteria. The second was not meeting the pre-activity criteria. And this first part which is there, it has got a small ambiguity. Here they had given A9, A8. So see the timings 18, 19, 19, 19, 18, 16. Time constraint is meeting. A3 is happening, no problem. A1, A4 is happening, no problem. A2, A5, A6, A2, A5, A6, and A6 के पहले A1, A3 has taken place, so no problem. A8, there is no restriction, only A3, A5 they have happened, so 8 will happen. Only I was facing dilemma about A9 and A10. Later on, the instructor clarified that though A9 is mandatory for A10, but they can happen on the same workstation. First A9 will happen, which will take 5 minutes, and then A10 can happen, which will take 13. So total 18. So this can happen. Okay, and with that logic, the option 1 which is there, it is the correct option. Is that clear?
Yes, sir.
Yes, sir.
Okay. Now in another PYP, they gave the same question, but they said that one product is made every 20 minutes. So in that question, only difference what will happen, now your min cycle time will become 20. Okay, so here this will come 20, 20, 20, 20, 20. 6 workstations. Okay. Now for once you have identified that this is the best layout out of all these options, what is the balanced delay for the line or the lines identified in the previous question? So the balance delay is nothing but the percentage idle time. Okay. And if you calculate, the total was 19. So 19 minus 19 minus 19 is 0. For all of them, they will be 0. 19 minus 18 is 1. 19 minus 18, 1. 19 minus 16, 3. So that's why I have taken 5 here. 5 by divided by number of workstations into min cycle time into 100, and the answer comes around 4.38. In the PYP, incorrectly this answer has been given as 5, which is not the balance delay but the time loss. Okay. Now, in case this is 20, then you will calculate this by using 20. So then it will become 20 minus 18, 20 minus 19, 20 minus 19. Is that clear? Is it okay?
Yes, sir, it's okay.
Okay, good.
Excuse me.
Yes, Afnan.
So, you mentioned, I think earlier, that to calculate the efficiency, instead of doing this
So,
100 minus
yeah,
percentage idle time, we can just calculate the efficiency directly. Now, isn't it possible then that we calculate the efficiency first and then subtract
yeah,
it
that
from
also
100
can.
to
Yes, yes,
get the idle time? Thereby,
yes.
we'll not have to subtract
Yeah,
all
both.
these
No, no,
things.
subtraction to, yes, yes, that also is possible. You're right. That also can be done.
The individual subtractions will not be doing
Yeah.
that in that case, right?
Yes, yes, that is also.
Yeah, yeah. Okay, okay. Thank you.
Yeah. Okay, now the next part of the same question. If a day has 2 shifts and each shift is for 8 hours, then what is the per day maximum output that can be achieved from the layout chosen as per the previous question number? So this, always remember that max layout, or sorry, max output is equal to total time divided by min cycle time, because this is the min cycle time. And total time, how much they have given? 2 shift, 8 hours, and this was in minutes, so this will become 60, and our this was 90, so this comes around 50.56. This is the max output. Okay, this next question is again from that economy, and the Bellman equation is solved using recursion for a 3-period inventory model. The ordering cost is 2,500, inventory holding cost is 250, material cost is 15,000 per unit. The item is sold at 30,000 per unit. The inventory can hold at most 30 units at any given period. Answer the given sub question. So this, please pay attention. It is a quite interesting question here, and this type of question has come twice in the PYPs. They have given, so question setup is what? There is a 3-period interval, 1, 2, and 3. The ordering cost is 2,500, which is the fixed cost. Inventory holding cost is 250. Material cost is 15,000 per unit. So material cost, this is the variable cost, 15,000. The item is sold at 30,000. Selling price is 30,000. This is a setup here. And the inventory can hold at most 30 units at any given period. So maximum what you can carry is 30 only, not more than 30. This is the basic setup for the question. Now they have written there are 20 units at the start of the second period. So this was the S1, S2. This is the second. So he has written there are 20. And the demand in the period is also 20. Demand is also 20. The possible future profit is rupees 747500. So here the profit in this stage is 747500. Irrespective of how many units are in the inventory at the end of the second period. So without saying whether it is 30 or less, your profit remains same. Then what is the maximum profit that can be generated up to period 2? What is the maximum profit which can be generated up to period 2? When the possible actions are restricted to ordering 0 or 10 or 20. So at stage this S1 which is there, your beginning state is 20, demand is 20, future profit they have given, and they have said irrespective what is the state here in the starting. And at this state, you can order either 0, 10, or 20. And they have asked what is the maximum profit. Now, if you just apply normal logic also, I have got 20, I have to consume 20. So why should I order anything? Because if I order anything, I will have ordering cost. Okay. And if I order something, then that quantity I will have to carry. So I will have carrying cost. So for the max profit at 2020, I will not order anything. Is it clear?
Yes.
Yes, sir.
Okay, very nice. So now if I don't order anything, so what is the profit which I will be earning here? I will be selling 30,000. So revenue which I will generate here, or the profit I'm generating, is 30,000 into 20. I'm selling 20. So this becomes,
Yes.
it stated how much it becomes? It becomes 6 lakhs. So my total profit now, how much it becomes? 6 lakhs plus 747500. Is this concept understood by everyone?
So,
Yes.
say if there was like certain, your inventory was 10. So
Oh,
you
yeah,
have to
yeah.
about 10.
I'll take that example also.
Okay, sure.
Okay. Suppose now they have given us 10. Now how much I should order? Instead of checking for 0, 10, and 20, logic says I should order only for 10.
Yeah.
Yes.
Okay. So when I order for 10, now my ordering cost will become 2500 plus 15,000 into 10. This is the amount which I am spending.
Yeah. Yeah.
Okay, so this total becomes 15000, 2500 will come here. This will come 152500. And how much I'm selling? Again, I'm selling for 6 lakhs. So my profit, how much it will become? 6 lakhs minus 152500.
Yeah.
And this I add to 74750. So that will become. In case I have only 0, then how much I should order? I should order 20.
Yeah.
Is that clear? So instead of checking all 0, 10, and 20, I have given you the normal logic that if it is 20, 20, don't order anything. If it is 10, 20, order only 10. Why should I have, carrying cost? If I got, if I got only 0, order only 20. If I got 10, order only 10. If I got 20, don't order anything. So that is the profit maximization. Okay. So in one of the question, they have given 20 and then 20. And in one of the question, they have said, you have got 10 and demand is 20. So I have covered both the scenarios. In fact, I have covered the third scenario also. I hope this is clear. Abir, Afnan, anyone, any doubt?
Yes. Yes, sir. It is clear.
Yeah, okay, very nice. Now, the second part of this question is that if the demand in the second period is non-deterministic and follows a distribution as given in the table below, then what is the probability that period 2 will end with 0 units in the inventory if the period 2 starts with 20 units in the inventory and an order is placed for 20 units? So see, he's saying that you are starting with 20 and period 2 starts with an order is placed for 20 and you are left with 0. You had 20, ordered 20. So what will be the demand here? If you are left with 0, 40.
Yeah.
And what is this is the probability for 40. So probability for 40 is how much? 0.125. Okay.
Okay.
Yes, sir.
Yeah. Okay. Sure. That is done. Okay. This is again the same question from the economy and business class. I leave this to you. Straight away question. Same formula. You find Py star. Use Py star in this formula, and then you get this is the protection level, and then you get the booking limit. Okay, this is the last question I will be doing because all other questions are of repetitive nature. This is also a very, very interesting question and it involves some calculations. It is about the inventory cost and the transportation cost. A company needs to ship two products, A and B, to a foreign country. Two models of transport, air and sea, are available for shipping. The demand in the foreign market is stable at 100 units per week. Okay, per week. This is per key for each of the two products. Product A and B cost rupees 20,000 and 10,000 respectively. If the company chooses to use air as the mode of transport, then it must ship 100 units in every shipment. This is a constraint. On the other hand, if the sea is chosen as the mode of transport, then the shipment size must be 400 units. So this is a constraint. Air shipment takes 1 week. This is the time to reach the destination, while sea shipments take 4 weeks. So this is the time. Items shipped by air incur a cost of rupees 360 per unit. This is the rate. Those shipped by sea incur rupees 90. This is the rate for sea. If the company incurs 20% of the per unit cost for the product as the cost to hold the item in inventory for a year, answer the given questions. So the setup is like that. The total demand for the year will be 100 units per week. So total demand will become 5200. Okay, for A item. For item A, price is 20,000. For item B, demand is same 5200, price is 10,000. Now you have got two modes, sea and air. Minimum how much you can carry, it is only 400. So this is your Q star. Time is in the sea is 7. It was 7 weeks or 7 days? 7 weeks. Okay, 4 weeks. Sorry.
Yeah.
So it becomes 28 days. Rate is 90 per unit. CO, ordering cost, here in this question they have not given, so it is 0. Holding cost is 20% of the price. They have given 20% of the price. So holding cost is 0.2 into price is 4,000. Once you come to air, what will change? Q star will change. They have given 100. Time will change. Time is 7 days. Rate will change. Rate is 360. CH will remain same, 4,000, and CO is 0. So this is for product A. For product B, what will change? Only CH will change, but the rest everything remains same. CH will be 0.2 of 10,000, which become 2,000. So now with the basic cost, we go ahead and start answering the questions. So the first question is, when shipping product A by C, what is the total inventory in the system? So I will cover certain important concepts. Okay, so the total cost in this case, they can ask, total cost is equal to ordering cost plus transportation cost and plus holding cost. Okay, in this case, ordering cost is 0. Now this holding cost also, which is there, it has got two elements. Holding cost has got two elements. One is Q star by 2, which was the annual into CH holding cost. This is you order, consume. So what is the total inventory in your warehouse? The second is there is inventory, the total demand which is there, for example, 5200, it always remains in some transit. So that transit time which is there into CH. So this is the second part of your holding cost. One is in your system or in your warehouse, and second is during transit. So these are the things which you have to consider. So this is the concept. Total cost is ordering cost. Ordering cost is nothing. How many times you order, D by Q star into CO. This is the ordering cost. Transportation cost is rate of transport. Rate of transport and how many items you are transporting. Okay. Holding cost, it has got two components, Q star by 2 into CH and plus transit holding cost, which is demand into CH into time. So time will is also a factor to this. Now with this concept, we go ahead and do these questions. So when shipping product A by C, what is the total inventory in the system? So total inventory in the system means both Q by 2 and the demand one, transit one. So this is in your warehouse and this is your in the transit. So for the C, minimum Q is 400. So Q star is 400. Total number of lots not required, otherwise I have calculated total number of lots will be 13 times. So you'll be ordering 13 times. So if there would have been an ordering cost, we would have used again this also. Inventory in the system is the average inventory in your warehouse, which becomes Q star by 2. And in the transit, the full inventory at any time, full demand will be transiting and time is 28. And we use days. So we convert days into years, 28 by 365, because this demand is for year, this is for year. Now we consider that one full year has got 52 weeks. And if you do without also, the answer will come 200 by plus 398.9, which is close to 600. So this is your inventory when you are shipping product A by C. Is this clear? Any doubt in this?
Could you repeat why is it 28, 5200 into 28?
28 is the time we have taken. See, when we go by C, it takes 4 weeks. Okay, so 4 weeks is 28 days. We convert 28 days to year because everything is in year. Okay?
Okay.
Yeah. So I have written these concepts here only. Now the second question is, what is the total cost that is incurred for the movement of product B by air? Okay. Now for the product B, minimum by air, Q star is 100. Total cost is ordering cost plus transportation cost plus holding cost. Ordering cost is 0 in this case. They have not given any ordering cost. Transportation cost is rate into demand. So rate is 360. The total demand is 5,200. So transportation cost for the year will be 187200. Is that clear? Now holding cost has got two parts. One is in warehouse, Q star by 2 into CH, which is 2000. Then demand into CH into time. So again, I have done the same, 7 days divided by year. So when you calculate this, this comes 300,000. And therefore, total cost will become 187200 plus 300,000, which is 217200. Any doubt in any step? Anyone? Abhi?
No, sir, no doubt. Absolutely clear.
Yeah, okay. So I have done okay, one by air, one by C, one for A, one for B. Rest okay, you can easily do. This is the concept. So if you understand this concept, easily you can do that. Okay, I think this was the most evolved question. Thereafter, okay, in the document I have solved it, so you can go through this. COVID, this is a simple question of VRP. You can use, just go ahead. This is a repetitive question. And this is EOQ, average inventory, and rest all questions are repetitive, and we have solved almost all of them. So this is the question which I had mentioned, that here they have mentioned that produce a product every 20 minutes. So here the min cycle time becomes 20. Okay. So with this, I have finished. If in case anybody is having any doubt or they want to add on something, please join here.
So that's pretty all right. Thank you.
Yeah.